We're going to look at the convex mirrors. Okay, so this is the part that we haven't dealt with yet. All right. As it turns out, though, all the rules are exactly the same to what we've been doing. The only difference is a different type of mirror. Okay. The key difference is this one is reflective on this side and non-reflective on this side. All right, whereas the other one, it was the other way around. Now you'll notice, okay, the focal point and the radius of curvature are both on the inside of this sphere, right? You can imagine the sphere is like this, and the image is on the outside of the sphere. So what this means is our focal point is negative. Okay, it's on the opposite side of the reflective side. Right? This is different than the concave mirrors that we've been doing. So it's something to keep in mind while you do this. All right, but in terms of all our rules so far, they're all the same. So we can just go through them. So the first one is a light ray will come parallel to this center axis point. All right, we'll draw our arrow. And we know that that would be, okay, if it came in parallel, it would go through our focal point. And so we line it up just like it would go through our focal point. The key difference here, though, right, is this is the reflective side. And so it's going to have to be reflected off the reflective side. So it would look like this. Now, this is called a diverging mirror for a reason. It's going to diverge the light always. It's not going to focus it. And so the key to our image formation and understanding the image formation is going to be to draw all our ray extensions, right? If you were a little person out here and you looked at this light, it would look like it was coming from inside the mirror. And so that's what we do. We draw that as if it was inside the mirror, right? Again, this is our reflected ray. And this is our ray extension, right? This is the real world. This is our virtual world. Everything on this side of the mirror doesn't actually exist. Okay, it's an illusion, basically, is what it is. All right, so that's the first ray that we can draw. So let's take a look at the second ray we can draw now. Okay, the second ray is very similar. If it's going through F, okay, so if we line it up with our focal point, all right, basically the opposite of the other one, will hit our mirror. And then if you recall, it'll come back parallel to our center axis. Again, this is the reflective side. And once again, when you're doing the diverging mirror, okay, or the convex mirror, we want to draw that ray extension. And so there's our ray extension. All right, so that's steps 1 and 2. You have, again, parallel to the axis, and it's reflected with the focal point, whereas this one, okay, reflected with the focal point, comes back parallel. All right, and the last one, slightly different, but we did cover it in the last video, is if you go through the center, so where the parallel axis meets the mirror, and this is the one that's going to come out the same as it went in. So you can see that we are at 18 degrees, and so we would go back up to 18 degrees in the other direction, and then we would line it up and draw our reflected ray. Okay. And this is the one, we'll just say drawn towards the center, where the mirror meets the axis. okay, reflected with the same angle. Now, this has a nice little treat to it. Just like before, all we have to do is draw at least two of these and find where they intersect. And so what I'll show you is actually if you take these, okay, these three images that we drew, we're going to reduce the opacity so we can line these up. Well, first it helps if we draw our extension ray. Don't forget to do that. That's the most important part. All right, here's our ray. Here's our extension. Now let's go ahead and try to overlap them. Okay, without the extension ray, you're not going to be able to tell where the image is formed. And so we can go ahead and line it up. And so you can see they both cross right here. So that would be sufficient, but of course, we have all of these, so why not do them all? So we're going to go ahead and clear this one out as well. We'll bring the opacity up a little bit. And there we go. So you can see, right, if you're off by just a little bit, that intersection point will be off. So you have to be neat, but two rays suffices. And so if we look at our two rays, here is where our image will be. Now you'll notice the image is, okay, on this side of the mirror. Image is virtual. The image is smaller. And the image is upright. All right, and if you've ever seen one of these mirrors before, which you definitely have, okay, it's in our classroom, you'll notice that they're often used so that you can see more of the surrounding area instead of less of the surrounding area. They'll use these in driveways so you can see around the corner of the driveway and things like that. And so that's the, this is always going to happen with a diverging mirror. They're going to be smaller. Right, so how do we take a look at this mathematically? Because drawing it is fairly simple. So let's say we have an object that is 5 centimeters high. It's placed 9 centimeters in front of a spherical convex mirror. Okay, diverging. It is important to know the difference between the two. All right, the radius of curvature of the mirror is 10 centimeters, and we want to know what the height of the image is and the distance from the mirror, whether it's real or virtual. So the first thing we know, right, we can find, we know the object is this high, it's placed here, and we know the curvature. And so what we could use, right, is our object distance plus our image distance is equal to 1 over our focal length. Now, we don't know what the focal length is, but we do know the radius of curvature is 10 centimeters, right? And we know that C is actually twice as far as F, or our focal length is C over 2. Now, in this case, remember, this is a diverging mirror. So if you were to draw it, F, it would be here, and C would be here. Your object would be on this side. So everything over here would be positive. Everything over here would be negative. So F is actually going to wind up being negative 5 centimeters. So we can go ahead and start solving this. So 1 over 9 centimeters plus 1 over SI equals 1 over negative 5 centimeters. Right, again, we can use centimeters because everything's in centimeters, so it's a common unit. Right. If you go ahead and solve this, you can do the common denominator. I suggest you just use your calculator. You should find that the image distance is, okay, negative 3.2 centimeters. Right, and remember this negative behind the reflective side. All right, that means our image is going to be somewhere over here, and it's going to be smaller. Now, the other thing we want to look at is we want to look at the, okay, whether it's going to be upright or inverted. And so we can find out that from using the magnification stuff. We do know that it's going to be virtual. This negative means it's virtual. It's behind that side. So let's go ahead now. We can use our other equation. And the other equation we know is the image height over the object's height is going to be equal to, okay, or the magnitude is going to be equal to our image distance over our object distance. And so this is something we know. HI is what we're looking for. Okay, the original object is 5 centimeters from the mirror. Again, we're looking at just the magnitudes, just the positives. We could look at the negatives, but again, this is in your reference table like this. So this is how we'll treat it. The image distance, right, is going to be the 3.2, and the original distance is 9. And so HI is going to be, if you solve this out, it should be 1.8 centimeters. All right, now, how do we know if it's upright or inverted? So that you can actually take a look at either your sketch or you could get it mathematically. This relationship is actually HI over HO equals negative SI over SO. If HI is positive, okay, then it's going to be upright. And if HI is negative, it'll be inverted. Okay, as a little aside, I always suggest that you take a look at the diagram really quick. It's not that challenging to sketch it out. For diverging mirrors, they will always be upright and virtual. Okay, they tend to go hand in hand if the object is virtual and it being upright. All right, so that's it for this video. The next one, we'll start some lenses.